Hello my dear children of class 11 science. Today again I welcome all of you through this mode of teaching that we are following, that is YouTube mode. And in today's class we do continue with the chapter flow of liquids. Okay, and in today's class we basically start some numerical problems. We solve some important numerical problem, and definitely I know that this numerical problem will help you to understand better in understanding the theory part of this chapter. Okay, now let me start with problem number 1. Now this problem is actually based on one of the theorem that you learned in the last class also, that is called Bernoulli's theorem. Okay, so the problem says that water enters a horizontal pipe. So what type of pipe is there? Horizontal pipe. And this pipe has non-uniform cross section. So what type pipe? So let me start with the solution of this problem. Directly I writing that for horizontal pipe, for horizontal what? Pipe of non-uniform cross section, non-uniform cross section means non-uniform cross section means having different area of cross section at the ends. Okay, now these pipes are placed in such a manner so that the water is flowing with a velocity of 0.5 meters, okay, and leaves from other end with a velocity of 0.7 meter. So at one end the water is entering with a velocity 0.5 centimeter. So I write that velocity as B1. Basically we know we have marked B1 is the velocity of water that enters at one end of the pipe, and that velocity is B1. This is 0.5 meter per second. And the same amount of water will also leave from the other end with a velocity that is given 0.7 meter per second. And I consider that is B2, 0.7 meter per second. Now children, one thing you need to understand. When water is already flowing and they are acquiring a velocity, then definitely this water has kinetic energy. Because the flowing water in a pipe acquire three types of energy. One is called pressure energy, one is called kinetic energy, and there is potential energy. But out here the potential energy will remain same, because the horizontal tube, so for horizontal pipe, okay, the potential energy at both the end will remain same. Okay, so both remain what? Same. Now question says that the pressure of water at the first end is 10 to the power 3 Newton meter square. Means I write that pressure as P1, that is 10 to the power 3 Newton per meter square. So this is the pressure at one end, at the first end of the water pipe. Means the end, that end where the water enters. Okay. Now this pressure is also the pressure per unit volume of the water that entering at one end. So what you need to calculate, children? Calculate the pressure at the other end, and you consider that pressure is P2. So P2 is the pressure at the other end of the tube. But what is flowing? Water is flowing, and water has a density. And you know what is the density of water? That is given 1 into 10 to the power 3 kg per meter cube. Okay. So when the water flows in a horizontal pipe, basically the energy which total energy per unit volume remain constant. But as I said already, there are only two energy which per unit volume remain constant. One is called pressure energy per unit volume, and one is kinetic energy per unit volume remain constant. So what I do, I write down using what? Bernoulli's theorem. Using Bernoulli's theorem, we have learned that the sum of what? Theorem for horizontal pipe. This is for horizontal pipe. The sum pressure energy, the total energy, let me just write down the total energy per unit volume, okay, is constant. The total energy per unit volume of the pipe remain what? Constant. Which means outer, as I said, total energy means one is pressure energy, is called kinetic energy per unit volume, and pressure energy per unit volume is given by P1, the pressure energy per unit volume entering at one first surface of the pipe, plus kinetic energy per unit volume means half rho B1 square must be equals to pressure energy per unit volume that is leaving from the other end of the pipe, that is P2, plus kinetic energy per unit volume that is leaving from other end of the pipe, which is given by half rho B2 square. And children, out here rho means the density of water. That means these two energy remain constant. Means the energy, pressure and kinetic energy entering at one end must be equal to pressure and kinetic energy leaving at other end. But this P1 is the pressure that is entering at first surface, and P2 is the pressure that is leaving from other surface. So in this problem we need to find this pressure P2. So let's substitute the value, children. P1 is how much? Basically how much? It is 10 to the power 3 plus half. Density is how much? 10 to the power 3. It's 1 into 10 to the power 3. This is simply 10 to the power 3. Now B1 means 0.1, but with what? Whole square, equals to P2 that we need to calculate plus half. Density of water is same density of water, that is 10 to the power 3 only. And B2 means how much? 0.7. This is 0.7 with what? Whole square. Okay, so let's simplify. This is 1000. I write then directly 1000 plus this is 1 by 2 into 0.5 square means 0.25 into 1000. Okay, into 1000 equals to P2 plus half. This is 1000. Okay, let me write 1000 into now 0.7 square means, children, 7 square means 49, but 0.7 square means 0.49. Okay, now we can simplify further. So this is 1000 plus now 0.25 into 1000. If I multiply and divide by 2 means we get approximately how much? 125. Okay, let me write directly 125. So this quantity now is 125 plus P2 plus now 0.49 multiplied by 1000. If you divide by 2, okay, we get approximately 245. Okay, now we can add this in the left hand side, that is 1125 equals to P2 plus 245. Okay, now to measure P2, I write down directly P2 equals to 1125 minus, now 245, if I'll take in the right hand side means minus, left hand side means minus 245, means the subtraction of this to measure P2. Now 1125, if you subtract with 245, we get approximately 880, and this is P2. Now P2 means the pressure that we are measuring, and the unit be Newton per meter square. What is the unit we follow? Newton per meter square. So what is the pressure that is exert at the other end of the tube? That is 880 Newton per meter square. So this is one of the simple numerical based on Bernoulli's theorem. Okay, now we go to the next problem, that is problem number 2. Alright children, now we are solving next problem. As I said, that is problem number 2, and the problem number 2 says that this is actually a problem based on terminal velocity that we measure according to Stokes law. Stokes law measure terminal velocity, that part we have learned in details, children. So let's solve this problem. Problem number 2 says that the terminal velocity of a copper ball. Now there is a metal ball but made up of copper. Now this is for copper ball. Okay, so terminal velocity of a copper ball of radius 2 millimeter. So radius R is given 2 millimeter. But I convert children this meter in millimeter into meter. Means 10 to the power minus 3 meter. So this is the radius of copper ball. Falling through a tank. There is a tank full of oil. Is how much? 6.5 centimeter per second. Means your terminal velocity is B. That is given 6.5 centimeter per second. So what I do? I convert this centimeter into meter. So basically what I do? I multiply by 10 to the minus 2, because 1 centimeter means 10 to the minus 2 meter, and second will remain same only. So the velocity is now 6.5 into minus 2 meter per second. This is the terminal velocity of copper ball. Now what we need to find, children? Find the viscosity of the oil. So viscosity of oil is basically expressed by symbol eta. So I mark eta as question mark. Now in this question, copper and oil density are given. Now the question says that the densities of copper and oil are 8.9 into 10 to the power 3 kg per meter cube. So 8.9 into 10 to the power 3 kg per meter cube is the density of copper, and density of copper is marked by letter rho. That is 8.9 into 10 to the power 3 kg per meter cube. And even oil has a density, and this is given by sigma. So children, sigma is the symbol we use for density of oil. That is 1.5 into 10 to the power 3 kg per meter cube. Okay, but children, in this particular case, and when we follow Stokes law to determine the terminal velocity of any metal solid, that solid should have more density than the liquid. That's why you see the density of copper ball is more than the density of oil. Okay, now to calculate the radius, I use the formula terminal velocity. Now I don't since from which law? Stokes law. From Stokes law, the terminal velocity is given by the formula B equals to, there is a formula I am writing directly, 2r square rho minus sigma g by 9 eta, and this g is the acceleration due to gravity. So what we need to find? We need to find what the velocity, sorry, not the velocity, eta, that means the coefficient viscosity. So I'll make eta as the subject. So I just do the interchange of eta and b. So can I write this way? So eta equals to 2r square rho minus sigma g by 9b. Okay, now let's substitute the value and calculate. So 2 into radius is 2 into 10 to the power minus 3 with whole square, r square means whole square. Okay, I'll put in a curly bracket. Rho means how much? 8.9 into 10 to the power 3 minus sigma means 1.5 into 10 to the power 3. Okay. Now children, in this particular problem, g means acceleration gravity. The value is not given, but we take the value as 9.8. What is the value we take? 9.8. Okay. Whole divided by 9 into b. Terminal velocity is this much. So let me put 6.5 into 10 to the power minus 2. So we can further simplify this. So when you do simplify, let me just multiply the quantity. Okay. So 2, it will be 2. 2 square means 4. 10 to the power minus 3 into square means minus 6. Now we can subtract this two quantity. 8.9 minus 1.5. If you subtract, it will be 7.4 into, with same common power is 3, with 9.8 divided by, now this is how much? 9 into 6.5. So 9 into 6.5 into 10 to the power minus 2. So we can do the calculation, children, and the calculation will be 4 into 4 is 8. Okay, 8 into 7.4 into 9.8. If you multiply, see, if you multiply this quantity, children, in the numerator, we get 500. How much? Yes, 80.11. So if you do multiply this quantity, we get 580.11 into 10 to the power minus 6 plus 3 means minus 3. Now minus 2, if I take in the numerator, is plus 2, or divided by 9.9 into 6.5. Okay. Now we can further simplify. 580.11 into 10 to the minus 3 plus 1 means 10 to the minus 1. And that 10 to the power 1, I'll take in the denominator. Now it will be how much? 9 into 6.5 into 10. Children, I hope you understood this part. 10 to the minus 3 plus 1 means 10 to the minus 1. But taking that 10 to the power minus 1 down means 10 to the power 1. 1 by 10 to the power 1. Okay. Now we can multiply denominator term. 9 into 6.5. If you multiply with 10, it will be 585. So I write in 580.11 divided by 585. Okay. Now we can divide this with the help of calculator. So if you divide, children, you get approximately in 2 decimal place, I write down, is 0.99. We write this in 2 decimal place only, 0.99, and this is what? The coefficient of viscosity. And children, for information, coefficient of viscosity can be expressed by the unit. The unit is what? Kg per meter per second. So we can write the unit kg per meter per second. So what is the final value of coefficient viscosity of oil? We are using calculating for oil, not necessarily water. Is 0.99 kg per meter per second. So this is the solution of problem number 2 also. So there are other problems also to solve, and that you will learn in the next YouTube video.